Hello and welcome back to another video. In this one we'll be solving a second order non-homogeneous differential equation. We must find the general solution for the following. Y double dash minus y dash minus 2y is equal to negative 2x plus 4x squared. Now, the typical solution for a second order non-homogeneous differential equation looks like this. Y is equal to yc plus yp, yc being the complementary solution and yp being the particular solution. We discussed these in previous videos that they will be in the description. Now our first step is to find the complementary solution, and to do so we must find the second degree equation from our second order differential equation. So we have y double dash becomes r squared minus y dash becomes r minus 2 multiplied by 1 as y becomes 1, and that is equal to 0. Now we must find the roots for the second degree equation to determine the value of the complementary solution. So we'll use the brackets method as it's easier than using the quadratic formula. So we have r squared, we get r squared from multiplying r by r. A positive multiplied by a negative is a negative. A negative multiplied by a negative is a positive. We must find two numbers that multiply to give us 2 and add up together to give us negative 1. So we have 2 and 1. Therefore, our roots are r minus 2 is equal to 0. Therefore, our first root is equal to 2. R plus 1 is equal to 0. Therefore, our second root is equal to negative 1. Since our roots are real in value and are different, our complementary solution is as such: c1 exponential r1x plus c2 exponential r2x. And when we substitute the values of r1 and r2, we get the following: c1 exponential 2x plus c2 exponential negative x. Now we have the complementary solution done. Now we must find the particular solution, and the particular solution is dependent on the value of the function of x, which is this part of the equation. Since our particular solution doesn't have an exponential or a trigonometric function, our particular solution would be as such: ax squared plus bx plus c. Now we must derive the particular solution twice to get y dash and y double dash to find the values of a, b, and c. So we have y dash is equal to 2ax plus b, and y double dash would be 2a. Now all we have to do is substitute the value of y double dash, y dash, and y into our original second order equation. So we have 2a minus 2ax plus b minus 2ax squared plus bx plus c, and that is equal to negative 2x plus 4x squared. Now we have 2a minus 2ax minus b, minus 2ax squared plus again, that's minus 2bx minus 2c is equal to negative 2x plus 4x squared. Now we match the following. So we have negative 2ax squared with 4x squared. So we have negative 2ax squared is equal to 4x squared. We can divide by negative 2x squared. Therefore, a is equal to negative 2. We have the value of a. Now, we have negative 2ax, negative 2bx, and minus 2x. So we have negative 2ax minus 2bx is equal to negative 2x. If we divide by negative 2x, we get a plus b is equal to 1. And since a is negative 2, b is equal to 2 plus 1, which is 3. Now we have the values of a and b. Now the only variable left is c, and we have the following equation: 2a minus b minus 2c is equal to 0. Now 2 multiplied by negative 2 minus 3 minus 2c is equal to 0. Negative 2c is equal to 7. C is equal to negative 7 divided by 2. Now we have the values of all three variables, a, b, and c. A is equal to negative 2, b is equal to 3, and c is equal to negative 7 divided by 2. Now all we have to do is to substitute them into our original formula. So we have a x squared, so we have negative 2x squared plus bx which is 3x plus negative 7 divided by 2. So our general solution would be y is equal to yc, which is c1 exponential 2x plus c2 exponential negative x plus the following: negative 2x squared plus 3x minus 7 divided by 2. And that would be our final answer. Thank you for watching. Like if you enjoyed, don't forget to subscribe and share if it's helpful. Thank you.